Hello and welcome. In this video I'll show you how to open the Ecovacs X9 Pro Omni. My unit is working perfectly fine. I was simply curious about which suction motor is installed. Is Ecovacs using Nidec motors with this unit, or have they switched to Kelly motors? Kelly motors are currently quite popular and are also used in Roborock devices. The robot itself is relatively easy to open, so I am going to mainly talk about a different topic. While inspecting it, I once again noticed a recurring issue common in many modern hybrid robots, especially those with mop rollers: airflow design. This robot is a perfect example of what happens when there simply isn't enough internal space. In my performance tests, it did very well on carpets, in some cases even outperforming the iRobot Roomba S9. It didn't quite reach Dyson 360 VisNav or AEG-RX 9.2 performance, but overall carpet cleaning was very solid, especially for a combo robot. On hard floors, however, performance wasn't as strong. The biggest issue with hybrid robots that include mop rollers is the lack of space for a straight airflow path. Every bend in the airflow reduces performance. We already saw this with the Roomba 705 combo, which I modified for airflow optimization. Simply relocating the exhaust by drilling an additional outlet hole in the bottom significantly improved performance because the airflow became more straight. The Ecovacs X9 Pro Omni shows a similar issue that pretty sure reduces the cleaning performance. Inside we find a Kelly BL30 suction motor. Unfortunately, there is very little technical information available online about this motor. The motor is mounted beside the dustbin, similar to the layout seen in the Roomba 980. However, the airflow is immediately directed against a wall because one of the main drive wheels sits directly behind it. This causes immediate airflow resistance and turbulences and multiple sharp bends in the airflow tunnel. The air is redirected upward, passes through noise insulation material, then bends again before finally exiting through the vent. All of this reduces cleaning performance. This design compromise is largely due to the space taken up by the mop roller. A straight rear airflow path simply isn't possible because key mechanical components occupy that area. Now let's continue with the teardown, because we've reached a critical point. There's a cable connected to the control panel on the top cover, and of course it's also connected to the main board, so be careful here. At the front you'll find small retaining tabs that need to be gently pressed inward. After that, it's best to slightly pull these two side panels of the housing outward. There are additional small clips there as well. Once those are released, start from the back, lift the housing upward, and then pull it forward to remove it, just like you can see here in the footage. So take your time with this step. It's manageable, but you don't want to force anything. You can also see that the charging module at the back is now loose. As I mentioned earlier, I strongly suspect that the green marked screws we saw before do not need to be removed. If you leave them in place, the charging module stays properly secured. The charging module also has guide rails on both sides, which is important when reassembling the robot. When putting the cover back on, start from the rear, align it properly with those rails, and then press the cover back down onto the robot. We can also see an additional weight at the front next to the main board. There was already one visible on the underside earlier. Now let's take a closer look at the suction motor. It's secured with two screws, and as mentioned before, it's a Kelly BL30 motor. And here, you can clearly see the issue I talked about earlier. The motor sits on the side and there's simply no room left to create a proper straight airflow path out of the housing. The air is partially guided by the top cover, but overall, the design is far from ideal. I'll most likely make a more detailed video about this. I'm even considering modifying this robot to create a straighter airflow path, just to see how much additional performance can be gained and whether there are measurable improvements. The robot already performed very well, but I'm convinced there's still potential here. This layout is probably also the reason why Ecovacs only installed an M6 filter. A higher grade filter might have created too much additional resistance within the already restricted airflow channel. I've already made a detailed video about filter performance and the whole filter topic. I'll link that in the description as well, including my response to some of the claims made by Vacuum Wars. There will also most likely be another video covering airflow design in several iRobot models. And that's it for this robot teardown. If you had to open yours, I hope this video helped you. Thanks for watching, and see you next time. Bye.